Hi, my name is Amanda Thompson, and today we'll be talking about molarity. Molarity is a fundamental concept in science that helps us understand the concentration of a solution. So grab a pen and paper while I explain what molarity is. Let's first start off with the solution. A solution is a mixture of two parts, a solute and a solvent. Let's consider a drink mix like Gatorade. In order to make Gatorade, you will need a liquid. In the Gatorade mix, you would have the drink mix and the water. The water is the solvent, and the drink mix is the solute. The solute, which is the drink mix, will dissolve into the liquid, the solvent, and you can always assume the smaller quantity is the solute. The liquid, which in this case is water, is the solvent. A solvent disperses and dissolves the solute, making the solution. We must note that water is a known universal solvent because it dissolves many ionic compounds and polar molecules. Molarity helps us understand how much stuff, the solute, is present in the water, the solvent. For example, if you add a lot of Gatorade mix to water, you'll have a high concentration, and if you add just a teaspoon of Gatorade mix, you will have a low concentration. So how do we mathematically represent these concentrations? That's where molarity comes in. It's helpful to think of molarity as a ratio. It's the amount of solute, which is the drink mix, compared to the total amount of solution, which is the drink mix in the water. The unit for molarity is a capital M. Now we'll be going over the formula of molarity. Molarity, which is capital M, is moles of solute divided by liters of solution. Solutes are measured in moles because 1 mole is equal to a very large number. In scientific notation, we would write that as 6.02 times 10 to the 23rd. What is the big number called?
600 into septillion 214
Moles in a
sextillion.
substance is derived from its molecular mass. Now remember, molarity is moles over liters. Now time for some practice problems. What is the molarity of 2 moles of sodium chloride dissolved in 1 liter of water? Grab a pen and some paper, pause this video, and give it a try. Don't forget to include your units. Hopefully you were able to try it on your own. If not, let's plug it in. So, we have 2 moles over 1 liter. Now, let's not overthink this. If we have 2 over 1, that gives us 2. Now we have 2 capital M molarity of NaCl. Now we have 2 capital M molar solution of sodium chloride. Make sure to always include your units to get full credit. Now we'll be solving for the molarity of lithium hydroxide, given the mass and the volume. Now what if our units aren't in the problem? We now have to convert. What is the molarity of 3 grams of lithium hydroxide dissolved in 300 milliliters of water? Pause this video, give it a try, and remember to check all your units. First, we need to convert 3 grams of lithium hydroxide to moles. Remember, 1 mole is equal to the molecular mass. Let's check out our periodic table for the masses of each element. Lithium has a molecular mass of 7. Oxygen has a molecular mass of 16, and hydrogen is 1. If we add those together, we should get a total of 24 grams. We're going to put X moles of lithium hydroxide over 3 grams of lithium hydroxide. This is equal to 1 mole of 24 grams of lithium hydroxide. Now that our variable of X moles of lithium hydroxide is set to our equation, our grams of lithium hydroxide will cancel out and we are left with our units of moles. Your answer should be 0.125 moles of lithium hydroxide. Now that we've converted our grams to moles, we have to do milliliters to liters to solve for molarity. Milliliters means 1 over 1,000, so in order to get liters, we would have to move the decimal point 3 places over, giving us 0.3. Remember, there are many ways to do conversion, so it's okay if your method is different. What's important is that you understand the method you choose to do. Now that we have both units, we can plug it into our molarity formula, which is 0.125 moles of lithium hydroxide over 0.3 liters of water. Once plugged in, we should get 0.417, and when rounded, we should get 0.4. Remember to include your units at all times, which is capital M. Now for example 3. What if we wanted to make a specific concentration of a solution? We would need to find out how many grams are needed to be measured for this concentration. Let's try it out. How many grams are needed to make a 0.5 molar solution of lithium fluoride in water? Pause the video and give it a try. Remember, molarity is moles per 1 liter of solution. So let's plug everything we know into our equation for molarity. We know that moles can convert to grams using our molecular mass, so let's find our molecular mass for lithium fluoride. Lithium has a molecular mass of 7 and fluorine a molecular mass of 19. When added together, you should get 26 grams. Now, 26 grams is equal to 1 mole of lithium fluoride, so let's set up a proportion to find the grams needed. The variable x grams of lithium fluoride divided by 0.5 moles of lithium fluoride. You're going to equal that to 26 grams of lithium fluoride over 1 mole of lithium fluoride. When you solve for x, you're going to multiply both sides by 0.5 moles of lithium fluoride. The moles of lithium fluoride cancel out and we are left with the unit grams. After solving, we should be left with 26 and 0.5, which gives us 13 grams. We would need to use 13 grams in order to get our 0.5 molar solution. Our total is 13 grams of lithium fluoride, and now we're done with example 3. Congratulations on learning molarity. We have learned to solve for molarity 3 different ways: when given moles and volume, mass and volume, and we've also learned how to solve for mass if given molarity. Thank you for joining me on this lesson for molarity. My team members were Zach and Genesis, and my name is Amanda.